Hello there, ATSEVS533 students. Dr. John Troggy here, giving you the last of the full lectures of this module of the course. There's also going to be a review or something like that, but that isn't really going to count as a lecture. It's just going to be something that I'm going to do to help you study. So this is our last lecture about what observations are telling us about climatology and climate change and so on. And today we're talking about the aspects that are associated with paleoclimate. Now, if paleoclimate is not a word that you're already familiar with, paleoclimate is a climate, a paleoclimate is a climate that was prevalent at a particular time or in the geologic past. It is climate of the past. We tend to use the word paleoclimate and paleoclimatology kind of interrelated. Paleoclimatology is specifically the study of the climatic conditions and their causes and their effects and so on in the geologic past, typically using evidence found in like glacial deposits and fossils and sediments and so on, as we're going to be seeing in this lecture. So this is going to be about not just like pre-industrial climate, the way we may have been thinking about and certainly will be thinking about more as we talk about modeling and so on. This is going back farther into the geologic record. What can we do? What can we know about the climate of the past? And well, that's actually a good question to ask, period, about how can we know something about the weather and climate of some number of years ago, some number of decades ago, some number of centuries ago, some number of millennia ago or more. What kinds of observations exist? What kinds of information can we glean from the natural world? What kind of inferences can we make based on that information? This is all really important, and this is definitely the subject of what we have come to call paleoclimate. Now, from a kind of philosophical point of view, we could talk about the more fundamental issue of how do we know anything about the climate outside of the current period. Well, we could talk about the fact that there are different ways of understanding the climate of the past based on different kinds of observations we take. And we're going to talk about 4 different kinds of records there are of climate of the past. This is a common theme, if you will, in atmospheric science classes. They often try to put their work into the context of this particular hierarchy, namely the satellite record, the instrumentation record, the historical record, and what we call paleoproxies, which I'm sure even by the name helps you know that in any lecture about paleoclimate and paleoclimatology will be particularly important. Alright, so let's talk about satellites. Okay, the satellite record. We certainly would like to be able to do climate science using satellites, and there's lots of advantages to satellites over the instruments that are at the surface of the Earth taking in situ observations. They have global coverage, they have just as much coverage over oceans as over land. There's lots of advantages to satellites, and satellites were tasked to do meteorological and climate work really from almost the time they were launched. Started. I mean, Sputnik was launched in, what, 59? The first crude meteorological satellites were launched, maybe the mid-60s. Certainly by the late 60s there were meteorological satellites. The problem was we didn't have meaningful systematic ways to actually archive the data from these satellites at that time. It really wasn't until about 1979 that a systematic way of globally archiving and preserving, making a permanent record of satellite observations really got started. 1979 is in many ways the most important year in the history of meteorology, because it was the year, just to tell you how this all worked here, that was the year of FIGGI, the first GARP global experiment. GARP was the acronym for a United Nations effort at that time about atmospheric research, and basically it was the giant international effort to get meteorological observations up to some standard of quality and to archive them, and in particular to do that with like satellite information and so on. So 1979 to present, well, that's a lot of satellite pictures. And keep in mind, when we're talking about meteorology and climate research and so on, the pictures are important, but that's only one of the things satellites give us. We can always recover via remote sensing techniques, things like, recover is not the right word, we can infer, or the right jargon actually is to retrieve temperature information, wind information, and so on from the satellite information. And now we have all that kind of information back to about 1979, which is about 40 years. That's a lot of meteorological information that, with the right logins set up on the right websites you have access to, I have access to. Anybody can get that data and do work on it as long as they know how to process the data and so on. So satellites are a great source of climate information, but they only tell us about the weather of the last, like, 40 years. There are certain kinds of climate studies we can do using this information, and 40 years is certainly a long period of time, but we really need longer observations if we're going to be talking about long-term changes in the climate. So let's go and start talking about the instrumental record, or sometimes the instrumentation record, whatever. These would be the kinds of high-quality in-situ observations, particularly at the surface, that are very, very useful for climate research. Now, we've talked a lot about how weather stations work and where they are and who operates them and so on. And we've even mentioned in the context of, like, temperature observations that many stations actually go back surprisingly far. You know, weather stations like the one, say, at the airport in Omaha have typically been there somewhere on the order of a century, okay? A lot of the weather stations in the United States were constructed about the era that airports were established, okay? So in the ballpark of like a century. The very longest operating weather station in the United States is in Massachusetts. I think it's called Blue Hill, and it's only like 120 years of observations. But there are stations in Europe and colonies that were set up by, you know, French explorers and so on that have longer records. Just to give you a sense, here's Hohenpeisenbergen. I speak German and even I can't. Hohenpeisenbergen. It's on a mountain, Hohenpeisenberg, in Bavaria. And it is actually the longest continuously operating meteorological station at high altitude, and it has been operating since, 1 January 1781. So, I mean, that's a very long climate record. There are similar observation stations that have been operating on the order of a few centuries at, like, the University of Berlin, the University of Cologne, the Sorbonne in France, and so on. There's a station at Oxford that's been running for about 250 years, and so on. But, compared to, you know, the routine observations that we take every hour now at airports and things like that, these are few and far between. But if you want to have some basic idea based on the instrumentation for the last few hundred years, especially in Europe and like, you know, there are more remote colonies, yeah, you can do it. You can do it. So the instrumental record is certainly important. It is how standard weather instruments give us climate information, and they're a great source of climate information, as long as we're only talking on the order of maybe a handful of decades to maybe a century, maybe in some limited applications a few centuries or so. That's as far as we're going to get with actual weather instruments. But we know paleoclimatology is going to be able to take us farther back in the past than that. I mean, you can flip through any climate textbook and see a figure that looks like this, and it's brilliant. I mean, this is giving us climate information for the last roughly 11,000 years, the Holocene. We'll learn about that vocabulary word in a little bit. And we can see we have global temperature anomalies over the last 11,000 years. We do not have any 11,000 year data sets from like thermometers or something like that. I mean, a plot like this is really cool. It helps us put, like, for example, the current warming really into context. I mean, look how bizarrely sharp the current warming is compared to anything that's happened during the Holocene. But how do we get this? What did busy little paleoclimatologists do all day to get information like this? I mean, goodness gracious. How did they get 11,000 years of global temperature information? Or from a different textbook, I found this one, which gives us like the last 400,000 years ago of temperature and actually carbon dioxide concentrations. How do we do that? Or take it farther back. I mean, here's a perfectly reasonable graph of global mean temperatures, or it's actually a proxy for global mean temperatures, but we'll learn about that in a little bit. For the last 4 million years. Well, what the heck? There weren't even humans at the beginning of this period. Or for that matter, here's the entire Cretaceous, tertiary period of geologic history. So it's about 65 million years ago. How do we put any of this into context? Where did they get all this stuff? Well, obviously that's where we're going with the remaining parts of this lecture today. But before we go just too crazy about that, let's go ahead and give a couple quick questions here. Question 1. If I want to use satellite estimates of surface temperature to study climate change, I'm only going to be able to examine the changes that have occurred in the last blank years. 4, 20, 40, 200. How long have we roughly had satellite observations that are useful for meteorology? Make a choice from those 4 options and get a little feedback before you move on to question 2.